Hello friends, I welcome you all to this class. This is real analysis class, and today we're solving this question under this topic, the absolute value. And this question, they ask us to find all the values of y elements of real numbers that satisfy the following inequalities. The first inequality is absolute value of y squared minus 3 less than what? 6. So let's find the solution to the first inequality. We have absolute value of y squared minus 3 less than what? 6. In the introductory part of this video, I told you that if you have that absolute value of x is less than epsilon, you know that absolute value of any quantity should be positive. So this x is just standing for any quantity. Any quantity can be inside this absolute value, but the absolute value of it must be positive. Any number that must be greater than a positive number must as well be what? Positive. So this epsilon must be positive, a positive quantity, and it must be a positive real number. Then, if this happens, this simply implies that what? This simply implies that this quantity inside this absolute value will lie between what? Negative epsilon and positive epsilon. So this quantity, whatever x is just any quantity inside the absolute value, it will lie between negative of this positive quantity here and positive of the quantity that is this epsilon. So here 6 is our epsilon here. So this quantity inside this absolute value will lie between negative 6 and what? Positive 6. So this is what we are going to have. So before we continue, we need to do what? We need to make y, we need to get y at the middle. So for us to get y at the middle, what do? We try to eliminate this 3 here, this negative 3 here. So how do we eliminate negative 3? We add positive 3 to both sides. Add 3 to both sides. So this implies if you add 3 to negative 6, we'll get negative 3 less than, if you add 3 at this middle, you have y squared left, less than, add 3 to 6, we have what? 9. We can break the inequality into 2, right? This implies that negative 3 will be less than y squared and y squared less than what? 9. But in this first one, if you take the square root of both sides, you'll be having what? You'll be having plus you must surely have what? Square root of negative 3, right? Because I don't want to go in detail evaluating it, because this will not give us the solution. Because if you take the square root of both sides, you'll be having square root of what? Negative 3. But you know that square root of negative numbers will give you what? A complex number, which is not a real number. So this will not yield a solution. We are going to focus on this one. Now, y squared less than 9 implies, so we can move, let's move 9 to this side. We know that if you take the square root of both sides, square root of positive 9 will give you what? A real number. So but because we're having inequality here, it's better we factorize it so that we'll be able to solve it. So let's move 9 to this side. If we move 9, we will now have y squared minus 9 less than what? What will be remaining at the right is what? 0. So this implies, let's factorize it, difference of two squares, right? This, because this is the same thing as y squared minus 3 squared less than 0. This implies y minus 3 y plus 3 less than what? 0. This is what we have here. So this simply implies, so the next thing we are going to do is to do what? To get the possible range of values of what? X that will satisfy this very inequality. So you can draw your real line. Here is what? Here is positive infinity. Here is negative what? Infinity. Then the first root you are going to get, if you set this to be equal to 0, you are going to get what? Positive 3. And you are going to get what? Negative 3 for y. Had it been you set this to be equal to 0. Now, having done this, you know 0 will be at the middle. Then having done this, you at the right hand side of this 3, pick any number there and test. 4 is at the right hand side of this positive 3. If you put 4 here, you are going to get 4 minus 3, which will be what? Positive. That's positive 1. And if you put 4 here, you get what? 7. So you are going to get a positive quantity. But we are having less than 0, right? That positive quantity will not be less than 0. So this side will not yield a solution. Pick a number between 0 and 3. Let me say 1. If you put 1 here, you are going to get what? We are going to get a negative value here. Pick 1, put 1 here, you are going to get positive. Negative multiplied by positive, you get negative. So this inequality will be satisfied because it will be less than 0. Then pick a number between negative 3 and 0. Let me say negative 1. If you put negative 1 here, you are going to get negative. Put negative 1 here, you are going to get what? Positive. So negative multiplied by positive, you get negative. Inequality will be satisfied. So all the numbers from here to here, all the numbers between 3 and negative 3 and 3 will satisfy the inequality. Then next one we are going to do, pick a number after negative 3. Let me say negative 4, for instance. Negative 4. If you put negative 4 here, you are going to get negative. Put negative 4 here, you are going to get what? Negative. Negative multiplied by negative, you get what? Positive. So this inequality will not be satisfied. So the inequality will be satisfied only between this that's here. This will give you the solution. This will yield the solution. But you know that if you put 3, let's check whether 3 will be among. If you put 3 here, you're going to get 0. And if you use 0 to multiply any point, you get 0. So we cannot be saying 0 less than 0, right? So 3 should not be among. If you put negative 3 for y, here will be 0. You will get 0 less than 0. So negative 3 should not be among. So, but all numbers between 3 and negative 3, excluding that 3 and negative 3, will give you the required solution. So the solution will be negative. We are going to have negative 3 less than y less than positive 3. This is what we are going to get, right? So the solution set, is, since we have strictly less than, we use open brackets, negative 3, 3. So this will give you the interval. I wrote the solution in interval form. So we are going to finish up the solving of the II in our next video.